The first problem we have in our lecture outline on atomic isotopes is the following problem. We want to give the isotopic symbol for an atom of beryllium that has the same number of protons, neutrons, and electrons. The symbol for writing an isotope is we're going to have our element, our mass number, and our atomic number. This is the basic format for writing our elemental symbol or isotopic symbol. X represents our element symbol. A is our mass number, and mass number is equal to the number of protons plus the number of neutrons. The isotope we want is going to have the following symbol. We have beryllium and the mass number A and the atomic number Z. So let's go ahead and create a table that shows our number of protons, neutrons, and electrons. If you look at the periodic table, the atomic number for beryllium is 4. The atomic number is like the DNA of the atom. It does not change. It's always the same for every element. Okay, and you get this from the periodic table. Because this is a neutral atom, it's going to have the same number of electrons. So it has 4 protons and 4 electrons. And how can we get the number of neutrons? Number of neutrons is going to equal the mass number from the periodic table minus the number of protons. And if we go to the periodic table, the mass number for beryllium is 9. And we know that the atomic number is 4. So that gives us a total of 5 neutrons that we have here. Now we're going to go ahead and create an isotope that has the same number of protons, neutrons, and electrons. So what we are allowed to change is the number of neutrons, because the number of protons and electrons will remain the same. So we have protons, neutrons, and electrons. The atomic number always is the same. The number of electrons always stay the same. And what we're going to need to do is we're going to need to change this to 4. Okay, so now our new symbol for the isotope of beryllium is going to have a mass number of 8, since it's equal to the number of protons and electrons, and the atomic number is 4. Let me write that more clearly. Let's go to the next problem on isotopes. We want to find the number of protons, neutrons, and electrons in neon 22. The 22 represents the mass number. And again, our symbol for our isotope is going to have our mass number at the top and our atomic number at the bottom. And we can go ahead and create a table that shows the number of protons, neutrons, and electrons. Remember that the number of protons does not change for an element, and for neon, if you look at the periodic table, it has 10 protons. And since it's neutral with no charge, it's going to have 10 electrons. And we know that number of neutrons equals mass number minus number of electrons. So if we plug that in, 22 minus 10 will equal 12 neutrons.